Hello everyone, my name is Ayush. I'm a master's student in computer science at NYU. In this video, I'm going to show you one of my favorite projects. It's called Semantic Map with Semantic Search, and I've built it using FAISS, UMAP, HDBSCAN, and TF-IDF. So what's the purpose of this app? Let's say you're building a very large scale data set, maybe for a text classification or generative model. So before you even start training your models, you might want to spot and remove sensitive or unwanted clusters. For example, content related to drugs or violence or insider trading or let's say personal data. So this app, it helps you do exactly that. It visualizes your entire data set semantically, lets you search phrases like things related to drugs, and then helps you see why those matches are semantically similar, even when they don't share the exact words. So here's what's happening behind the scenes. I've taken a very large text corpus. I used the 20 news groups dataset. I took that dataset and each document in that dataset I then converted into a 384 dimensional embedding using mini-LM from sentence transformers. Then I've done two things. I first reduced the embeddings with UMAP to 15 dimensions for clustering and then to 2 dimensions just for the visualization that you see here on the screen. And then I've clustered the points using HDBSCAN, which groups similar meanings together. So each color you see here on the map, it represents a semantic topic like sports, health, or politics. Finally, we store all the vectors, all the embeddings inside a FAISS index. So that's what powers the app's fast semantic search. Okay, so now once the clustering is done, I have loaded everything into a Streamlit app. Here, each dot you see, it represents one document. As you can see here on the screen, when I hover over these dots, you can see the exact document that it represents. Okay, and now on the left, uh, there's a sidebar where you can filter by cluster. So these are the all the clusters that were made during this document building phase. You can even type a keyword filter like, for example, drug, and you can see, and you can also enter a semantic search query like things related to drugs. Okay, let me type it in and show you what happens when I hit enter. Right. So when I hit enter, the app uses FAISS to find the top case semantically closest documents, even if they don't contain the exact words. So what you're going to see in a while, right, so here it is. As you can see, the white marks on the map, these represent the semantic hits with our query, which is things related to drugs. Now let's strip away all the other irrelevant documents for this query. So as we can see, we've got some hits. So when I hover over these X marks, we can see, right, okay, they have some content which are related to our query. Now, below, we can also see the exact ranked list of the top 10 semantic matches with cosine similarity scores. As you can see, the number one has a cosine similarity score of 0.55 and so on up till the 10th one. So all, we can see the exact documents that were similar to our query. Okay, so this tool is especially useful for data cleaning and audit before training large models. So if you're preparing text for an LLM, you might want to visually inspect where topics like drugs or violence occur in your dataset. And then you can even mark them for removal using the removal bin feature here before the data even reaches your model. So let's say I want to remove this document from our dataset. I'm going to add it to the removal bin. And as you can see, we've got a list, right? I can add multiple documents and on the sidebar, you can see the marked for removal counter increases. And then I can even download the documents that we have marked for removal. We can get their IDs, we can get their we can get the exact documents and we can remove it from our data set before it even reaches the model for training. Okay, so you might notice that each cluster, it has names like cancer or health or medical, right? So there are these names, they are automatically generated using a technique called CTF-IDF. Here's how it works. So as you can see there, each cluster has its own name, a group of three words. So how are these generated? So instead of computing TF-IDF per document, I've treated each cluster, so one color you see on the screen, as one giant document. And for each word inside that cluster, I've calculated how unique it is to that cluster compared to all the other clusters. So if words like cancer and treatment, they appear often in one cluster but rarely in others, they get a high CTF-IDF score. And that's how the cluster gets labeled cancer, health, and medical. Now, one of the coolest parts of this app is this section right here, the why are they close explainer. So when you click on one of the top matches, let's say I'm going to choose the number one match, uh, we can see a TF-IDF breakdown that explains why the query, which we've input here, things related to drugs, and the retrieved document, which we can see here, the number one, the first one, they are semantically similar. So let's look at the example that we've shown. We search for things related to drugs. The top hit has a cosine similarity of 0.552, which means it's moderately close in the embedding space to the query. So the explanation, we get to see these three panels here. First, the word drug appears in both the query and the document. So you will see these three numbers here, the query weight, doc weight, and the joint score. So the query weight, it shows how important the word drugs is in the query. The doc weight shows how important the word drugs is in the document, right? And the joint score, it shows the combined strength. It is roughly the product of the two weights, of these two weights. Okay. So this panel shows that the shared word drugs, it strongly contributes to why they're close. Okay, in the next panel, we can see words like related and things are strong in the query but not present in the document. So their weights show what's unique to your side. So like the side of the semantic query that we've input. And in the final panel, uh, it's about the doc only key phrases. So the document, it contains phrases like theories, data, and study, right? So even though these don't appear in the query, the embedding model understands that drugs, they often co-occur with medical research terms. That's why FAISS, it found it semantically close. So together, this panel explains both the lexical overlap via TF-IDF and the semantic proximity via cosine similarity in the embedding space. So to summarize the core stack, I've used sentence transformers for embeddings. I've used UMAP for dimensionality reduction, HDBSCAN for density-based clustering, CTF-IDF for automatic cluster labeling, FAISS for the fast semantic similarity search, TF-IDF for the human readable explanations, and I've used Streamlit for the interactive front end. So in short, this app, it gives you a visual overview of your data set in the semantic space, a search interface that works with natural language. You can even filter by clusters. You can search for things inside that cluster. We also get a TF-IDF based explanation of why each match is semantically similar to the input query. And the most important part is we can get a removal bin to flag sensitive and noisy data before that data even hits training. So that's the semantic map with semantic search project. If you enjoyed this walkthrough, please drop a like and subscribe for more projects. More content is coming soon. I'm going to be walking through many AI research papers and AI concepts in the future. So thanks for watching.